seen the electronic concept of oxidation and reduction. Oxidation is, so you remember, oxidation is loss of electron or a removal of electron. And the reduction, that is the gain of electron or addition of electron. Gain of electron or addition of electron, and that is the electronic concept of oxidation and reduction. Now let us see the oxidation number concept. Oxidation number concept of oxidation and reduction. We have seen what's meant by oxidation number. Oxidation number is the net positive or negative charge seen on one atom of the element in its compound or in its ion. In the compound or in the combined state or in the ionic form, the charge, positive or negative charge, carried by one atom of the element, that is called the oxidation number. If the charge is positive, then we say the element is in the positive oxidation state. Positive oxidation state. Then the oxidation numbers will be +1, +2, +3, +4, etc. Okay. If the element is in the negative oxidation state, then we say the charge is negative. Then we say it is in the negative oxidation state. Then charge is negative. Charge of the atom will be negative, and the oxidation number will be -1, -2, -3, -4, etc. Okay. Now let us see the oxidation number concept of oxidation and reduction. Oxidation number concept. Oxidation number concept of oxidation and reduction. Now, oxidation is a simple definition. Oxidation is an increase in the oxidation number. Increase in oxidation number. We need this for the second year. We need this for the second year. The increase in the oxidation number, that is called oxidation. While reduction is a decrease in the oxidation number. This is called a reduction. Suppose oxidation number is equal to 0 and that is changed to -1. So there is a reduction in the oxidation number. +10, +9, see the origin. Here, say +5, then +4, +2, +1, 0, -1, -2, -3. See. So 0 is changed to -1. 0 is changed to -2. 1 +1 is changed to -1. +1 is changed to 0. In all these cases, there is a reduction in the oxidation number. Suppose +5 is changed to +2. Oxidation number is decreased. Suppose +7 is changed to +2. There is decrease in the oxidation number, and that is reduction. Suppose -2 is changed to 0. There is an increase in the oxidation number. -2 becomes 0, increase. -2 becomes +2, increase. Or 0 becomes +1, increase. 0 becomes +2, increase. 0 becomes plus 3, increase. And the increase in the oxidation number is that is called oxidation. Let us take an illustration, an example. Let us take. You take the reaction between zinc and copper sulfate, blue copper sulfate. In copper sulfate, there are Cu plus 2 ions. Cu plus 2 ions, blue in color. Now, you add zinc into Cu plus 2 solution. Then you will get the Cu copper plus Cu Zn plus 2. Zn plus 2. Here we can see the oxidation and the reduction. When you speak about the oxidation and the reduction, you consider only the reactants. What happens to the reactants? Maybe the electronic concept, maybe in the oxidation number concept. Whichever concept it is, you think of what is happening to the reactant. What is happening to the reactant? The oxidation is for the reactant. The reduction is for the reactant. So what happens to the reactant? Whether there is loss of electron from the reactant, oxidation. Whether there is addition or gain of electron by the reactant, reduction. Similarly, whether there is increase in oxidation number of the reactant, oxidation. Decrease in the oxidation number of the reactant, that is a reduction. Now you come to this. The reactants are, which are the reactants here? Zn, zinc, and Cu plus 2. Cu plus 2. What are on the left hand side are the reactants? Okay. What are on the left hand side are reactants. So on the left hand side here we have Zn, zinc metal, and the Cu dipositive. Now, what is the oxidation number of Zn? Zn is a metal that is in the atomic state, that is in the elemental state. And what is the oxidation number of Zn? Evelyn, can you help me?
0.
Oxidation number of Zn is equal to 0. That is in the atomic state, elemental state. Remember the rules, Elemental state, oxidation number is equal to 0. It's equal to 0. Now you come to the right hand side, Cu, copper. Copper. That is also in the elemental state, metallic state, elemental state. In the elemental state, a charge, oxidation number is equal to 0. Now, you think of the changes for the reactants. What happens to Zn? See here, Zn is converted to Zn plus 2. Zn is converted to Zn plus 2. Now what happens to the oxidation number of Zn? Is it increased or decreased? Alvin? What happens to the oxidation number of Zn? Is it increased or decreased?
Increased.
You say?
Increased.
Yeah, it increases. Same. Oxidation number of Zn was 0. Now 0 is changed to plus 2. 0 changes to plus 1, 0 changes to plus 2, 0 changes to plus 3. There is increase in the oxidation number. And therefore, this is the oxidation reaction. It is an oxidation because there is increase in oxidation number. Increase in oxidation number. So Zn is oxidized to Zn plus 2. The same thing we have studied when we were dealing with electronic concepts. Is it not? During this change, what happens to Zn? From Zn, 2 electrons are lost. From Zn, 2 electrons are lost, forming Zn plus 2. Loss of electron, that is oxidation, electronic concepts. Here, increase in the oxidation number. So oxidation, same oxidation here also. Okay. Now what happens to Cu plus 2? Cu plus 2. Cu plus 2 is changed to Cu0. Is changed to Cu0. Then what happens to the oxidation number? Alvin, you can try again. Alvin, you can try. Oxidation number is or decrease?
Decreases.
Decreases. Plus 2 to plus 1, decrease. 2 to 0, decrease. Plus 2 to minus 1, decrease. Plus 2 to minus 3, decrease. So there is decrease in the oxidation number, and therefore that is a reduction. This reaction is a reduction because there is decrease in the oxidation, decrease in the oxidation number. So that is a reduction. You consider the electronic concept. Then Cu plus 2 is converted to Cu. Cu plus 2 gains 2 electrons. Cu plus 2 gains 2 electrons. Gain of electron is reduction. Here also there is reduction. There is no change. But only the concept is changed. Electronic concept, and here we have the oxidation number concepts. Okay. Increase in the oxidation number, oxidation. Decrease in the oxidation number, that is a reduction. That is called a reduction. Okay. Now, here there is a system consisting of Zn and Zn plus 2. Say a system consisting of the oxidized form and Zn, that is the reduced form. Similarly, Cu plus 2, the oxidized form, and the Cu, that is the reduced form. A system consisting of the oxidized form and the reduced form together, that is called a redox couple. That is called a redox couple. Redox couple. What is couple? A pair. Two persons. Two things. That is couple. The newly wedded couple. The newly wedded couple. The bride and the bridegroom. Couple. So two persons or two things. Couple. So here we have two things. Zn plus 2 and Zn in the first case. Second case, Cu plus 2 and Cu. Second case. There is a couple of the oxidized form and the reduced form. Oxidized form and reduced form. And such a couple is called a redox couple. We need this for the second year. In second year, there is electrochemistry. In electrochemistry, the redox couple will be coming. So a redox couple is a system consisting of the oxidized and the reduced form of a substance. That is called a redox couple. Okay. In some cases, we can see that some ions are unstable. Some ions are unstable. And they change, say like this. For example, you take a Cu plus 1 ion, Q plus ion. that is unstable in water. And so it easily changes to Cu plus 2 and Cu. Cu plus 2 and Cu. There is only one reactant. Remember, here there is only one reactant. And the reactant is Cu plus 1 ion, copper 1 ion, copper 1 ion, 2 plus ion. It is called a 2 plus ion. Copper 2 ion, Cu plus 2 ion. It is called a cupric ion. Cuprous and cupric. Here, cuprous ion, Cu plus 1 ion, copper 1 ion is unstable. And so it easily changes to Cu plus 2 and Cu. Cu. Remember, here there is only one reactant. One reactant. Now you say, what happens to the reactant Cu plus 1? What happens to the reactant Cu plus 1? Is it oxidation or a reduction? Tell me, Achut. Is it oxidation or reduction? Cu means Cu0. What happens to Cu plus 1? Is it oxidation or a reduction? You think of it.
Oxidation, sir.
Why do you say it is oxidation? Come on, give the explanation. For everything, there should be a reason. There should be a reason. Why do you say it is oxidation? What is oxidation? In terms of oxidation number? Arjun?
It loses.
No, electronic concept. Now you come to the oxidation number concept. Oxidation number concept. What is oxidation?
Net positive or negative charge on one atom of element.
Number. And what is oxidation? In terms of oxidation number? In terms of oxidation number, what is oxidation? Define oxidation.
I don't know, sir. I don't know.
You don't know why? Okay. Evelyn, please help me. What is oxidation?
Increase in oxidation number. Increase in oxidation.
Or decrease? You say which is
Increase.
oxidation, which is reduction.
Increase.
Oxidation. That is it not? Now you take a Cu plus 1. What happens to Cu plus 1? Cu plus 1 is changed to Cu plus 2. Cu plus 2. Is it oxidation or reduction? You say, Evelyn? You say, is it
Oxidation.
there is a increase in the oxidation number? You think of another change. There is a second change. And the second change is this one. The same Cu plus 1. The same Cu plus 1 is converted to Cu0. Now, Evelyn, you say, is it oxidation or reduction? Come on,
Reduction.
that is reduction. There is reduction. Reduction. Okay. So, ultimately, what happens to Cu plus 1? Is it oxidation or reduction? Yeah, you say, Evelyn. It may be a
Redox.
is it oxidation or reduction? The final reaction. Yeah? Come on.
Reduction.
Only you think of the bottom reaction. You think of the bottom reaction. Come on. Hey,
Both.
look at here. You say You are confused. You think of the definition. Increase in oxidation number, oxidation. Cu plus 1 is converted to Cu plus 2. Increase in oxidation number. So that change is oxidation. Right? Decrease in oxidation number, reduction. Cu plus 1 is converted to Cu0. There is a reduction in the oxidation number. Decrease in the oxidation number. So this reduction. Now my question is this. During these changes, which reaction occurs there? Is it oxidation or reduction? That is my question. Munya, please help.
Both.
Oh, yes, there you are, correct. There is oxidation and reduction. When one ion of Cu plus 1 is oxidized, another ion, you see here there are two ions. Out of two ions, one is oxidized and the other is reduced. So the oxidation and the reduction is for the same reactant. Oxidation and the reduction for the same reactant. Simultaneous oxidation and the reduction for the same reactant. Such a change is called disproportionation. Disproportionation. Disproportionation reaction. Disproportionation reaction. That is a simultaneous oxidation and reduction for the same substance. The simultaneous oxidation and reduction. Oxidation and reduction. Oxidation and reduction for the same substance. For the same substance. Same reactant. Same reactant. Same reactant. That is called a disproportionation reaction. Disproportionation. We need this for the second year. Disproportionation. For the same reactant, there is oxidation and reduction. There is increase in the oxidation number and a decrease in the oxidation number. When one half is oxidized, the other half is reduced. When one ion is oxidized, another ion is reduced. One ion increase in oxidation number. For the other ion, there is a decrease in the oxidation number. And such a change for one and the same reactant, one and the same substance, that is called a disproportionation. This is what is called the disproportionation reaction. Is it time to stop? Up to what time I have to take the class? 1 hour. Up to 1 hour. Okay. So this is called a disproportionation reaction. It is not given there in your notes. It is not given there in your notes. So you just add this. You add this reaction to your notes. You add this equation. So all of you who are behind the curtain, all of you behind the curtain, please add this reaction to the last page. So Cu plus 1 giving Cu plus 2 plus Cu0. Then you show the reduction and oxidation. Reduction and oxidation. Then you write a disproportionation. Proportionation, yes. Disproportionation. Now you write the definition. Simultaneous oxidation and reduction for the same substance. That is, increase and a decrease in the oxidation number for the same substance. That is called a disproportionation. Is it all right? Okay. So it finishes our chapter, the redox reactions. This much is enough for us. Okay. Now, let me go to organic chemistry. The fundamentals of organic chemistry you have studied in the 10th standard. So let me begin from the 10th standard itself. What is organic chemistry? What are organic compounds? You have studied in the 10th standard. Organic compounds are the compounds containing carbon. So carbon compounds are collectively known as organic compounds. These are called organic compounds. So organic compounds are carbon compounds. These are the compounds of carbon compounds. These are called organic compounds because the first compounds were found in the organisms, micro or macro organisms, plants and animals. So the substances present in organisms, plants or animals, organisms, in that sense, the carbon compounds were known as organic compounds. You know, there was a belief that organic compounds could be synthesized by the action of some kind of mysterious forces found in the living objects. And that is called the vital force theory. Do you remember 10th standard? The vital force theory. I had taught you this. Vital force theory. Vital force theory. Say, vital force theory is the belief that organic compounds are synthesized by the action of some kind of life forces, some kind of vital forces present in the living organisms. Say, organic compounds are synthesized, are produced. They are produced by some kind of vital forces, or life forces present in the living organisms. There was a belief like this. And this belief that was known as the vital force theory. That means organic compounds can be synthesized by living organisms, living objects only. That means they cannot be synthesized in the lab. Organic compounds are not man-made. They are not man-made compounds. Man-made compounds. It was the belief. It was the belief under vital force theory. There is no man-made organic compounds. But Wheeler, the mischievous scientist, Wheeler, he was the person who shook the vital force theory. The vital force theory was overthrown. It was questioned and overthrown by Wheeler's synthesis of urea. Wheeler's synthesis. Wheeler's synthesis of urea. Synthesis of urea. Actually, it was not a synthetic method. It was not a synthetic method. He was doing some other experiments with the cyanides. Cyanides. He was heating ammonium cyanide, NH4, CNO, that is ammonium cyanide, ammonium cyanide. He was heating it. See, ammonium cyanide is not an organic compound. That is not an organic compound. It is inorganic compound. But Wohler heated ammonium cyanide. Not ammonium cyanide, he was heating potassium cyanide plus ammonium sulfate mixture. Then ammonium cyanide was formed in the mixture. And what happened, you know, do you remember? Ammonium cyanide was converted accidentally, quite accidental. It was not a purposeful reaction. It was not an intentional reaction. It was an accidental reaction, accidental discovery. Majority of the discoveries are accidental. There was a formation of a urea, say CO, NH2, NH2, urea. And urea is a purely organic compound. And this reaction is called Wooler's synthesis of urea. So here, the inorganic compound was converted into the organic compound urea. Urea is present in the urine of all the animals. It is present. So urea, the compound produced in the living system, it was produced by Wooler in the lab. But this was an accidental discovery. So majority of the discoveries, good discoveries are accidental. Accidental. That man was taking rest in the garden, say under the apple tree. Do you remember that man? He was taking rest. He was enjoying the breeze. Yes. And at that time, what happened? The apple was falling down. No. And say, if I were there, what would happen? I will take the apple and eat it. Say, eat it suddenly. And look at the apple again. When the second apple is going to fall down, I will be waiting for that. Oh, so many apples are there. Only one apple has fallen down. I'm so hungry. Okay, that will be my thought. But that man was not thinking in that line. He was thinking, why the apple is falling down? Why is it not going up? Why is it not going up? It is falling down. He tried. He took the apple and he threw it upwards. Say, it went some distance up and it was falling down again. He tried it. He was not trying to eat it. Such a foolish man he was. Sorry. So, and that accidental falling down of the apple led to the discovery of gravitational force. No. See, similarly, majority, see, Archimedes principle. He was taking bath. He was in the bathtub, completely nude. At that time, so water was overflowing, eureka. Ran out of the bathtub, even without the dress. Think of it. Accidental discovery. So majority of the good discoveries are accidental. See here, the accidental discovery, ma'am is waiting here. So the accidental discovery of urea by heating ammonium cyanide. And with this, the vital force theory was questioned, and ultimately it was overthrown. More details we can see in the coming class. Now it is time. Let me stop now. Thank you.